According to the 2023 National Electrical Code, specifically Section 334.15b, Romex, which is non-metallic sheathed cable, generally does not require conduit when it is run in accessible locations. These locations include spaces above ceilings and hallways. However, a crucial aspect to consider is that the Romex must be adequately protected from physical damage. Now turning to mechanical code requirements, it is important to understand that the specifics can vary depending on the local jurisdiction. Many jurisdictions have requirements in place to ensure all holes are properly sealed. This is done to maintain air tightness and to prevent unwanted drafts. A reference point for this type of requirement can be found in the International Mechanical Code, specifically Section 301.21, though this is dependent on the jurisdiction. Addressing the distinction between commercial and residential codes, apartment complexes are generally classified as commercial buildings. It is essential to be aware that commercial buildings typically have more stringent code requirements compared to residential buildings. It has been stated that the requirement to seal holes around air handler units is a new code rule. This is not necessarily true, as such requirements have been in effect for quite some time. Anticipating the electrical inspector's opinion, it is probable that they will also require the holes around the air handler units to be sealed. Furthermore, they will likely ensure that the Romex is properly secured and protected from any potential physical damage. However, it is less certain whether they will mandate the use of conduit for the Romex. To proactively address these concerns and avoid potential issues during the electrical inspection, it is highly recommended to take the necessary steps to seal the holes around the air handler unit. Additionally, ensure that the Romex is secured in accordance with the requirements outlined by the National Electrical Code. This approach will help to ensure compliance and a smooth inspection process. When dealing with electrical installations, several key factors must be considered to ensure safety, compliance, and optimal performance. These factors range from understanding the relevant codes and standards to selecting appropriate materials and installation techniques. Here is a detailed overview of important aspects to keep in mind. Firstly, it is essential to have a thorough understanding of the National Electrical Code, or NEC. The NEC serves as the cornerstone for electrical installations in many jurisdictions, providing comprehensive guidelines and requirements for safe and effective electrical systems. Familiarize yourself with the latest edition of the NEC and any local amendments or interpretations that may apply in your area. Secondly, it is important to determine the appropriate wiring methods. The NEC recognizes various wiring methods, each with its own set of applications and limitations. Common wiring methods include Romex, also known as non-metallic sheathed cable, conduit, and cable trace. Select the wiring method that is best suited for the specific application, considering factors such as the environment, voltage levels, and the need for physical protection. Thirdly, consider circuit sizing and overcurrent protection. Properly sizing circuits and providing adequate overcurrent protection is critical to prevent overheating, electrical fires, and equipment damage. Calculate the load requirements for each circuit, taking into account both continuous and non-continuous loads. Select the appropriate wire size and overcurrent protection devices, such as circuit breakers or fuses, in accordance with NEC guidelines. Fourthly, grounding and bonding should be considered. Grounding and bonding are essential for safety, providing a path for fault currents to flow back to the source and tripping overcurrent protection devices. Ensure that all metal enclosures, equipment, and conductive parts are properly grounded and bonded in accordance with NEC requirements. Pay close attention to grounding electrode systems, bonding jumpers, and equipment grounding conductors. Fifthly, understand wiring connections and terminations. Proper wiring connections and terminations are crucial for reliable electrical systems. Use appropriate connectors, terminals, and splicing methods to ensure secure and long-lasting connections. Follow manufacturer's instructions and NEC guidelines for making connections and terminations, paying attention to torque requirements and insulation ratings. Sixthly, consider the environmental considerations. Electrical installations must be able to withstand the environmental conditions in which they are located. Consider factors such as temperature, humidity, moisture, and exposure to corrosive substances. Select materials and equipment that are suitable for the environment and take precautions to protect wiring and components from damage. Seventhly, understand the requirements for special locations. Certain locations, such as hazardous locations, wet locations, and healthcare facilities, have additional requirements in the NEC. Be aware of these requirements and take the necessary precautions to ensure safety and compliance. This may involve using specialized equipment, wiring methods, and installation techniques. Eighthly, perform inspections and testing. Regular inspections and testing are essential to verify that electrical installations are safe and compliant with applicable codes and standards. Conduct visual inspections to identify any defects, damage, or non-compliant conditions. Perform electrical testing, such as continuity tests, insulation resistance tests, and ground impedance tests to ensure that the system is functioning properly. Ninthly, document your work. Proper documentation is essential for future reference, maintenance, and troubleshooting. Keep accurate records of all electrical installations, including wiring diagrams, circuit schedules, equipment specifications, and inspection reports. This documentation will be invaluable for anyone working on the electrical system in the future. Lastly, stay updated with code changes. The NEC is updated every 3 years, and it is important to stay informed of any changes that may affect your work. Attend training courses, read industry publications, and participate in professional organizations to stay up to date on the latest code requirements and best practices. By keeping these factors in mind, you can ensure that your electrical installations are safe, compliant, and reliable. Remember to always consult with qualified professionals and adhere to applicable codes and standards. Now, let's delve deeper into each of these aspects, providing additional details and examples to enhance your understanding. Beginning with the National Electrical Code or NEC, it is essential to recognize that the NEC is not a static document. It undergoes revisions and updates every 3 years to incorporate new technologies, address emerging safety concerns, and improve clarity and usability. Therefore, it is imperative to always refer to the latest edition of the NEC to ensure compliance with current requirements. In addition to the NEC itself, many jurisdictions adopt local amendments or interpretations that may further modify or clarify the code. These local requirements may be based on regional conditions, historical practices, or specific safety concerns. It is your responsibility to be aware of and comply with all applicable local amendments or interpretations in addition to the NEC. Moving on to wiring methods, the NEC recognizes a variety of wiring methods, each with its own set of applications and limitations. Romex, or non-metallic sheathed cable, is a common wiring method used in residential and light commercial construction. It consists of 2 or more insulated conductors encased in a non-metallic sheath. Romex is relatively easy to install and is suitable for dry locations where it is protected from physical damage. Conduit, on the other hand, is a rigid or flexible tube used to enclose and protect electrical conductors. Conduit provides excellent physical protection and is suitable for both indoor and outdoor applications. Different types of conduit are available, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit, each with its own set of advantages and disadvantages. Cable trays are used to support and route cables in industrial and commercial applications. They consist of open structures or channels that allow cables to be easily installed, inspected, and maintained. Cable trays are particularly useful for large cable runs or in areas where frequent changes or additions are anticipated. When selecting a wiring method, consider factors such as the environment, voltage levels, and the need for physical protection. For example, in a wet or corrosive environment, conduit may be the preferred wiring method to protect conductors from moisture and chemical exposure. In areas where cables are subject to physical damage, such as in industrial plants or construction sites, conduit or cable trays may be necessary to provide adequate protection. Next, concerning circuit sizing and overcurrent protection, properly sizing circuits and providing adequate overcurrent protection is critical to prevent overheating, electrical fires, and equipment damage. The NEC provides detailed guidelines for calculating the load requirements for each circuit, taking into account both continuous and non-continuous loads. Continuous loads are those that are expected to operate for 3 hours or more at a time, such as lighting, heating, and air conditioning. Non-continuous loads are those that are not expected to operate for extended periods, such as appliances, power tools, and receptacles. To calculate the total load for a circuit, add up the continuous and non-continuous loads, and then apply any applicable demand factors or diversity factors. Demand factors are used to reduce the calculated load for certain types of loads, such as lighting and receptacles, based on the assumption that not all loads will be operating simultaneously. Diversity factors are used to reduce the calculated load for multiple circuits or feeders based on the assumption that not all circuits will be loaded to their maximum capacity at the same time. Once you have calculated the total load for a circuit, select the appropriate wire size and overcurrent protection devices in accordance with the NEC guidelines. The wire size must be large enough to carry the calculated load without overheating, and the overcurrent protection device must be sized to protect the wire from overloads and short circuits. The NEC provides tables and formulas for determining the appropriate wire size and overcurrent protection device for various types of circuits and loads. Addressing grounding and bonding. Grounding and bonding are essential for safety, providing a path for fault currents to flow back to the source and tripping overcurrent protection devices. Grounding refers to the connection of electrical equipment and systems to the earth, providing a reference point for voltage and a path for fault currents to dissipate safely. Bonding refers to the connection of metal enclosures, equipment, and conductive parts to each other, creating a low impedance path for fault currents to flow back to the source. The NEC requires that all metal enclosures, equipment, and conductive parts be properly grounded and bonded in accordance with specific requirement. This includes grounding electrode systems, bonding jumpers, and equipment grounding conductors. Grounding electrode systems consist of one or more electrodes that are used to connect the electrical system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Bonding jumpers are used to connect metal enclosures, equipment, and conductive parts to each other, creating a low impedance path for fault currents to flow back to the source. Equipment grounding conductors are used to connect the grounding terminals of receptacles, equipment, and appliances to the grounding system. Wiring connections and terminations are often overlooked. Proper wiring connections and terminations are crucial for reliable electrical systems. Poor connections can lead to overheating, voltage drops, and equipment failures. The NEC provides detailed guidelines for making wiring connections and terminations, including the use of appropriate connectors, terminals, and splicing methods. Connectors are used to join two or more conductors together, providing a secure and reliable electrical connection. Different types of connectors are available, including wire connectors, crimp connectors, and mechanical connectors, each with its own set of advantages and disadvantages. Terminals are used to connect conductors to equipment, such as receptacles, switches, and circuit breakers. Terminals must be properly sized and installed to ensure a secure and reliable electrical connection. Splicing methods are used to join two or more conductors together, creating a continuous electrical path. Different splicing methods are available, including twist-on connectors, crimp connectors, and solder connections, each with its own set of advantages and disadvantages. When making wiring connections and terminations, it is important to follow manufacturer's instructions and NEC guidelines, paying attention to torque requirements and insulation ratings. Torque requirements specify the amount of force that must be applied to tighten a connector or terminal, ensuring a secure and reliable electrical connection. Insulation ratings specify the maximum voltage that a conductor or connector can withstand without breaking down, ensuring that the electrical system is properly insulated. Moving on to environmental considerations, electrical installations must be able to withstand the environmental conditions in which they are located. This includes factors such as temperature, humidity, moisture, and exposure to corrosive substances. In areas with high temperatures, it may be necessary to use conductors with high temperature ratings to prevent overheating. In areas with high humidity or moisture, it may be necessary to use conductors and equipment that are specifically designed for wet locations. In areas exposed to corrosive substances, it may be necessary to use conductors and equipment that are resistant to corrosion. The NEC provides detailed guidelines for selecting materials and equipment that are suitable for various environmental conditions. This includes requirements for conductors, raceways, enclosures, and other electrical components. In addition to selecting appropriate materials and equipment, it is also important to take precautions to protect wiring and components from damage. This may include using conduit to protect conductors from physical damage, installing drip loops to prevent water from entering enclosures, and providing ventilation to prevent overheating. Now, understanding requirements for special locations. Certain locations, such as hazardous locations, wet locations, and healthcare facilities, have additional requirements in the NEC. Hazardous locations are areas where flammable gases, vapors, or dust may be present, creating a risk of explosion or fire. The NEC provides detailed guidelines for electrical installations in hazardous locations, including requirements for explosion-proof equipment, intrinsically safe circuits, and other safety measures. Wet locations are areas where water or moisture may be present, creating a risk of electric shock. The NEC provides detailed guidelines for electrical installations in wet locations, including requirements for watertight equipment, ground fault circuit interrupters, and other safety measures. Healthcare facilities are areas where patients are undergoing medical treatment, creating a risk of electrical shock or interference with medical equipment. The NEC provides detailed guidelines for electrical installations in healthcare facilities, including requirements for isolated power systems, ground fault protection, and other safety measures. These requirements can be found in Article 517. Finally, performing inspections and testing is an important and crucial step to the process. Regular inspections and testing are essential to verify that electrical installations are safe and compliant with applicable codes and standards. Inspections should be conducted by qualified individuals who are familiar with the NEC and local requirements. Inspections should include a visual examination of the electrical system to identify any defects, damage, or non-compliant conditions. Testing should include continuity tests, insulation resistance tests, and ground impedance tests to ensure that the system is functioning properly. Continuity tests are used to verify that electrical circuits are complete and unbroken. Insulation resistance tests are used to verify that the insulation on conductors and equipment is in good condition and is not allowing current to leak to ground. Ground impedance tests are used to verify that the grounding system is functioning properly and is providing a low impedance path for fault currents to flow back to the source. By keeping these factors in mind and following the guidelines provided in the NEC, you can ensure that your electrical installations are safe, compliant, and reliable. Remember to always consult with qualified professionals and adhere to applicable codes and standards.